all of us are trying to find the path to AGI, especially all the AI researchers that have been in the field of AI from a very long time, and all the researchers who are working at companies like DeepMind and OpenAI, and all the frontier large language model companies. So we have seen what are frontier large language model companies or frontier AI companies, and we know what are foundational models. So the foundational models are great at next token prediction. They are great at understanding the whole world, and they are great at simulating the internet. They have been trained on a large amount of data that is there on the internet, and they can do great next token prediction in an autoregressive way, such that it helps us do sentence continuation. It helps us, do a lot of code completion. And now we have, multimodal models also, right, that can tackle different modalities of data. Now, what we really want is a path to AGI, right, which is artificial general intelligence, a hypothetical state, a speculative state where we are envisioning certain things that we will achieve super intelligence, right? So, what is the path to AGI? In one previous video, we talked about hyperscaling laws. Today, we are going to think about or talk about agentic systems. Is agentic AI, the multi-agent systems, is that the real path to AGI systems? So this is what we are going to discuss today. Okay. So before we answer the direct question whether multi-agent system or agentic AI is going to lead to a path to AGI. So LLMs are going to evolve to multi-agent systems, and multi-agent systems are going to lead to the path of AGI. First, let's define the anatomy of the whole multi-agent system or agentic stacks, right? So in the base model, or in the first level, we have the base model, which is known as our cognitive model, or our cognitive engine, or our thinking engine, or our non-deterministic LLM that is sitting on this layer, that is helping us do the non-deterministic, the creative, the language understanding stuff, right? So this is like the brain and the non-deterministic uh, creation engine for our agentic stack, right? Now we have something which is known as the agent scaffold, or the chain of thought engine, the controller engine that helps us plan all the tasks. So this is our planner. This maintains or manages our state, right? Since we are going to do a series of tasks in the whole agentic workflow, so we need a state management, we need a memory, right? And we need a planner. So this is where, this is the layer that manages everything, right? So we also call them agent scaffold or agent scaffolding. So this is a very commonly used term when we are talking about agentic systems. Then we have the controllers, the actuators, the environment, right? So where we want to place our tools. For example, we want to integrate web browsing, we want to integrate the tools where we want to impact whatever task and whatever generation that we have done, and whatever context we have understood from the problem. It's so this is the layer where we want to impact, right? So the actuators helps us bridge the digital cognition with digital impact, and sometimes it is physical impact, right? So all the API connectors, code execution sandboxes, virtual machines, virtual boxes, web browsing tools, all of them lie at this layer. Now the last loop, or yeah, I think the last and one of the most important loop, is the feedback loop, right? The self evaluator. It helps us understand how well did we do. So now once we have understood the agentic stack, so we know that agentic AI and multi-agent system are very proactive in nature, right? LLMs are very reactive in nature. So this is one of the reasons which helped researchers and the community believe that this is how we will reach AGI, right? So why? Because they could observe that all the multi-agent system, the agentic AI system, are very proactive in nature. They are oriented to achieve a goal, right? They are very goal driven. They are very task driven. Whereas the LLMs are simply next token predictors, and they are very reactive at inference. So if you are running at an LLM at inference time, unless you give a prompt, it's not going to reply, right? So they wait for the prompt, but the agentic systems don't only wait for the prompt, they are always capable of making independent decisions irrespective of the prompt, right? The prompt might have been instantiated once, but if once they are in action, they are capable of making their own decisions, right? The other reason is that these systems utilize agent scaffolding, right? All the external code that manages planning, persistent memory, state, and tool usage is scaffolded, right? Now the other one more reason that helped us believe that these multi-agent system and the agentic AI systems might help us achieve AGI is that they are hierarchical and specialized agents. When I say hierarchical, so I basically want to signal that we can have multiple agents to accomplish one task. Let's say we are doing a collaborative goal and we have a root agent. Under the root agent, we have a coder agent. Under that, we have a tester agent, and we have an execution agent. So multiple agents are collaborating, giving feedback, validating each other's code, and validating each other's task and output to accomplish a certain goal, to accomplish a certain task, right? So all of this behavior can be characterized within two words, which is hierarchical specialized agents, right? So we have specialized agents to accomplish certain tasks, and we have a hierarchy among them, a topology among them, to understand which agent is triggered when and whether it can be parallelized or not, right? So this basically tries to mimic a human organization unit, a large human organization that acts as a collective intelligence, and that is oriented or driven to accomplish a complex task in a collaborative manner. Yeah. So with this multi-agent system, I mean, if we view multi-agent system from this paradigm, it seems that they are high agency, they are high, they have high autonomy, and they can act as autonomous system. So this might be one of the path, or one of the more promising path to AGI. So what exactly is the concluded opinion? Is multi-agent system the only path to AGI, or is it one of the promising paths to AGI? So agentic AI and multi-agent systems are very sophisticated orchestration layers, right? They enhance the utility of LLMs because they are helping LLMs accomplish a task. So, and they're also evolving from the monolithic architecture of LLMs to a human organizational architecture of a system that can collaboratively collaborate to accomplish a certain task, right? But the fundamental problem is they are not breaking through a main problem, which is machine cognition. They are not enabling machine cognition. The intrinsic architecture that is helping us play out everything is the transformer architecture, because there is an underlying LLM which is acting as the base model in agentic system, which is nothing but a next token predictor, right? Which does not have the cognitive abilities of a human brain, right? So the grounding problem that we have not yet bypassed using these multi-agent system is cognitive scaling wall. So we have discussed the cognitive scaling wall in the previous video also, where we discussed about hyperscaling and how is hyperscaling paradigm, you know, as a how is hyperscaling paradigm viewed as a path to AGI, right? So we can produce certain autonomy and certain autonomous system using this multi-agent system architecture, and we can automate very complex digital workflows. But true intelligence requires a transition from statistical probabilistic next token prediction to grounded causal world modeling. So I mean, we know that we are able to mimic the human organizations and we can automate complex workflows using the multi-agent system, but true intelligence or true general intelligence is changing or might require a sense of cognition, a sense of thinking ability, a sense of mimicking a human brain rather than mimicking an organizational structure. And we might want to transition from the statistical probabilistic n-gram manipulation to causal world modeling, right? So the future of the field is likely demanding us to integrate high level semantic LLMs with low level physics aware world models, a hybrid architecture that can reason in language and act in reality. So until this integration is achieved, agentic AI will remain a powerful tool for task automation and accomplishing certain digital workflows, but an incomplete candidate for AGI, right? So I think with this we can conclude, or with this we can have an opinion that AGI is not going to be only accomplished using multi-agent systems.